Good day everyone, my name is Viknesh, son of Subramaniam, and I have completed the assignment 1 with the guidance of Professor Madhya Dr. Muhammad Aizal bin Jamaluddin. As you can see, my question for this assignment is question 1, which is given load impedance 150 minus 75 imaginary ohm to match a 50 ohm line at 500 megahertz, and I have to design this L section matching network. From here you can see that I have already pinpointed the main points from this question, where the load impedance, the characteristic impedance, the frequency, and I have also calculated the normalized load impedance, which is 3 minus 1.5 J. My next step would be is to plot the normal impedance, which I have calculated just now. As you can see from this diagram, first diagram here, there is a red circle here, and there is where the normalized load impedance is. And since the normalized load impedance is inside the unit circle, I have drawn in a dark black pen, and here, as you can see from this diagram, when the load impedance inside the unit circle, we have to use this circuit, which is this circuit, and where the ZX will be in the series part and JB will be in the shunt part. The next step would be, after we get the normalized load impedance, after we plotting it, first rotate the unit circle in by lambda over 4, and then try to find the admittance with the normalized load impedance, which I found just now, and the admittance is 0.267 positive, J 0.133. The next step is, with the admittance we have calculated just now, we have to find the y1 and y2 value, where it is the distance between the admittance and the blue point and the green point, which is touching the unit circle. As you can see, the values is y1 and y2 have been stated at the left hand side of this presentation. And after that, for first we have to use y1. Let's use the y1, which is in the blue circle, where we can find the b value by taking the imaginary part of it and calculating the distance between the admittance and the y1, where we got the value is 0.317. and the next step is rotate the point y1 point to the back to the unit circle just now, and as you can see, we'll get y imaginary 1, which equals 1 minus 1.66 imaginary. As you can see, we can get the x value by taking the center of the Smith chart, imaginary part of it, j0 minus j negative 1.66, and we will get positive value 1.66. As you can see just now, we have found the b value and the x value, and both values were positive. And from the notes I have given here, and just focus at the highlighted part, where when b is positive we have to use this formula, and when x is positive we have to use this formula to find the capacitance and inductance. With those formulas, I have already successfully found the capacitance and the load impedance, and the inductance. After that, we can easily get our first solution, which we use the y1. This is the first design by using it, where the inductance will be at the series part and the capacitance will be in the shunt part. The next step would be is by using the y2, which is in the green circle. First we have used the y1, right, and now we are using y2. With the y2 is the similar method we used just now, and now we can find the both values b2 value and the x2 value. After that, after we get the both values are in a negative value. As you can see from the nose, just now was positive value and now is negative value. We have to use these formulas which is already highlighted to find the inductance and the capacitance. With those formulas, I have already successfully found the capacitance and the inductance value, and our second solution for this question is this diagram where the capacitance will be in a series part and the inductance will be in shunt part. So thus this question has two solutions. Thank you for listening to my presentation.